Spaceflight impacts the body in numerous ways, and scientists have found that it is hard to study because of expense and the unknown variables of space. As a solution to this problem, they have found that bed rest has similar qualities to spaceflight. I'm Emma Baker.
And I'm Nikita Ewest.
And we are here to discuss the similarities and why bed rest is beneficial to spaceflight studies.
Some of the physiological effects include bone loss, muscle loss, loss of blood volume, changes in vision, and changes in nutritional needs. But one of the major physiological effects of spaceflight is bone and muscle loss. When astronauts are in space, the zero-gravity atmosphere allows for little use of bone and muscle because there are less forces acting on the body. When patients undergo bed rest, the side effects are similar because there is little to no movement, which allows for scientists to use this to predict bone and muscle loss for spaceflight. In one study, 12 physically fit men agreed to undergo 60 days and nights of bed rest to better understand the effects of spaceflight on the body. They were positioned at a 6-degree head-down tilt, including no bathroom breaks, no showers, and no sitting up to eat or drink. Because astronauts lose bone and muscle at about the same rate as bedridden people on Earth, this study gave scientists the opportunity to test these changes.
To demonstrate how much bone and muscle loss occurs during spaceflight, we found a research article detailing 3 manned spaceflights. This research study was conducted on the Skylab, the first U.S. space station opened by the United States, and it spent 6 years orbiting the Earth. The 3 studies conducted lasted 29, 56, and 84 days. During that time, they recorded a calcium balance analysis along with pre- and post-flight single photon densitometry of the arm and calcaneus. They wanted to see how much bone density would decrease during their time in space. These studies showed that a calcium balance reached about negative 300 milligrams per day by 84 days in weightlessness. The researchers also documented that bone was not lost equally from all parts of the skeleton. They measured the distal radius and ulna and the calcaneus to find these results.
While the astronauts were in space, they did daily exercise to see if that would affect bone density loss, and the longer the flight, the more exercise they did. They concluded that the exercise helped with reducing the amount of strength lost. The participants on bed rest also did exercise, and they found that it reduced the bone and muscle loss as well.
This topic relates to our course because it gives an overview of the physiological effects of bed rest in spaceflight. These physiological effects are bone and muscle loss because of zero gravity and lack of use. One key factor that helps lessen these negative effects were consistent exercise.
In conclusion, spaceflight is expensive and hard to study because of all the unpredictable variables, so scientists have turned to studying bed rest. They have similar effects in bone and muscle loss, and the key way to counteract these effects is consistent exercise. Thank you for listening to our presentation, and if you have any questions, please post them below.